If you are tired of writing long electron configurations, this is the video for you. We are going to learn the shortcut today, how to shortcut the system. Now to shortcut it, what we're going to end up doing is cutting out the core electrons. So if you remember, we talked about valence electrons. Those are the electrons in the outermost edge. Well, that means that if you're not a valence electron, you're a core electron. You're in the middle. You're tucked inside. You're not on the outer edge. So those core electrons don't really do much, so we don't really care if they're included in the electron configuration. So if you're tired of writing 1s2, 2s2, 2p6 over and over again, you get to cut that out, and what you're going to end up doing is cutting out those core electrons by using the noble gas using the noble gas in a bracket, and that will represent the core electrons. I'll show you what I mean in a second. Just get these notes down for now. So you take the noble gas, you put it in a bracket, and then you continue your electron configuration from there. Now, which noble gas do you use? Well, you use the noble gas that is the previous one, the most previous one to the element that you're doing. So you take your element, go backwards on the periodic table until you come to the first noble gas that comes before it. That's the one that goes in brackets. So here's what we're going to do. We're going to do a little example. So if you remember from this, you got the off-bow chart. You go 1s2, right? 2s2, you follow all that. As you're doing that, you follow this. I'm going to show you, instead of using this, you can actually use the periodic table. On the periodic table, you got the period. This is like our 1, so we put our 1 here. 1, we're in an S block, so that's where the S comes from. Then we go 1, 2, whoops, 1, 2. We went 2 through the S, the first 1S sublevel. Then it goes 2S, 1, 2. After that, we go 2. We're now in the P block, so we go 2P. And then if I go 1, 2, 3, 4, 5, 6, 6. After 2P comes 3S. And if you don't believe me, check over here. 3S, 1, 2. I jump over here. I'm at 3P. Let's go all the way across. 3P6. 3P6. After 3P comes 4S. So we got 4S2 here. There's 2 elements, so 4S2. Let's actually do manganese. Let's stop at manganese here. Let's say we're doing the electron configuration manganese. Notice there's a 3 here. This 3... it jumps down from 4 to 3. That's because after 4S comes 3D. 3, I'm in the D sublevel, so I go 3D. And manganese is 1, 2, 3, 4, 5 elements in, so I know manganese is 3D 5. So that's how you use the periodic table. Go back and watch that again if you need to. One thing I didn't mention in the previous video that I regret forgetting to mention is that these numbers here, these tell you the energy level like this. They do not tell you the period number. So if I ask you which period manganese was in, it is in period 4, not period 3. These are still my period numbers over here. So those are still my period numbers. These are just little hints for you to help you do the electron configurations. Okay, now I'm going to do the same thing. For argon. If I were to write argon's electron configuration, it would be 1s2, 2s2, 2p6, 3s2, 3p6. So if you notice, argon's electron configuration is exactly the same as manganese electron configuration up to this point. And one thing else, remember, argon is the element that is previous to manganese. So manganese is 25. Obviously, krypton comes after. Argon is the one that comes before it. So if these two electron configurations are exactly the same, what's the point of wasting my time and writing all of it? So what I'm going to do instead is I'm going to take all of this, and I'm going to write it as AR in square brackets. So what I do is I take argon, because it comes before manganese, I write it in square brackets. Then from argon, I work my way from argon back to manganese. Argon, after that, I go 4s, 4s2, and then 3D, 1, 2, 3, 4, 5. 3D, 5. So notice that this is the same as this. And if you were to calculate the valence electron of manganese up here, you'd say, okay, 4 is my highest energy level. It has 2 valence electrons. Same thing here. If I look, okay, 4th energy level, argon has 2 valence electrons. So the trick to this is that if you always take the previous noble gas and write your electron configuration from there, your electron configuration will still include the valence electrons, which are the most important ones, and it dumps out all of these core electrons, which really we don't care about in chemistry very much anyways. So that's the nice thing about this. Now, you might be a little bit reliant on this thing yet, this off-bow chart, but you're going to want to get rid of it because it doesn't help you do shorthand notation. So you do have to figure out how to use this periodic table. The off-bow chart would be a mess to try to figure this out. So let's do a few examples. Let's do germanium to start with. Germanium is number 32. Now if I look 32, I go over, here's my noble gases. My noble gases are group 18. So I'd say, okay, krypton is after germanium. Argon is right before. 18 comes before 32. So I know that I'm going to start my electron configuration with argon in square brackets. Then I go argon 4s. I go all the way through, so 1, 2, 4s2. Then I'm at 3d. So I go 3d, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All the way across is 10. Now notice I'm back up to 4, and I'm in the P sublevel, so 4P, and then I count 1, 2. Germanium is 2 into the 4P sublevel. So that would be germanium's shorthand electron configuration. Let's do cobalt here. Cobalt is number 27. I'm going to erase this so that we can start fresh. So cobalt is 27. Again, argon comes before it, so I would go argon. And then I would go 4s2 because I'm going through here, so I got to work my way from argon. Argon's 18, so I go at 19, 20, and then cobalt is all the way right there. So 4s2, 3d, 1, 2, 3, 4, 5, 6, 7. It is 7 in. I want you to do sodium. Pause, do sodium, and try osmium on your own. Now we're back, and sodium is right here, number 11. So 10 comes right before it. So I would put neon in brackets this time. We've got a new one, neon, because sodium is 11, neon comes before it. And then sodium is 3s, and then is 1 into that block. And that is it. So this does shorten it up quite a bit, you see. Osmium, pause it if you want to stop and do osmium if you haven't yet. It is 76. So I go back, 86 comes after, 54. So xenon is my previous noble gas. Remember, your noble gases are all, these are your noble gases. Xenon in square brackets. Now from xenon, 54, I go through 55 and 56, which is in the 6s sublevel, 6s2. Now, the trick here, though, is 56, I cannot jump straight across here because this is 71. I've actually got to go down to here. 57 comes next. This is the 4F block. I've got the 4F block. Now, if you count all the way across the F block, it holds 14 electrons, so there's 14 across. After I hit 70, now I come up to 71, because 71 comes after 70. And now I am in the 5, so you see this 5 here, 5D. And then osmium, to get to osmium, I need to count 1, 2, 3, 4, 5, 6. 5d6. So osmium shorthand would be xenon, 6s2, 4f14, 5d6, which is a heck of a lot shorter than starting from up here and going through all of these from the very beginning, 1s2, 2s2. It really makes this a lot easier. Okay, now here's another type of practice. I'm going to do the first two a little quicker, I'll do the first one a little slower, explain myself, then I'll have you pause it, do the rest as practice, and then I'm just going to go through and give you the answers very quickly to finish out the video. So the first one, to do this, I look, okay, I've got argon, so I started argon is right here, then 4s2, I go through the 4s, then 3d5, so I'm in the 3d, 1, 2, 3, 4, 5, that would be manganese. So 3d5, I find myself at manganese. So the identity of this is Mn. If nothing else, if you want to do it this way, argon is 18. You got 2 plus 5 is 7 electrons, so 18 plus 2 plus 5 equals 25. So you got element 25. That's another way to do it. Manganese, going all the way back, it is in period 4. It is not in period 3. That 3 is not the period number. So it is in period 4. It is in group 7. If I go up, it's in group 7. And it is in the D block. So I would put D for D block there. The next one is xenon 6s1. So I've got xenon. If you do the trick where you go xenon is 54 plus 1 electron. So I've got element 55, which is cesium. CS. Or just go xenon. Okay, we got 6. And this is the S block. It's 1N, cesium. Same way to do it. This is in period 6. We go to the side. The period is on the side. The group number, it is group 1. And it is in the S block. What I'd like you to do is pause the video, do the next couple in your note packet on your own, and I'll quick give you the answers here in a second. Okay, this one looks kind of tough to add up to me, so I'm just going to do it this way. Krypton, after that, 5s2, 4010 all the way across, and then 5p1, 2, 3. I've got antimony. So SB is antimony. One thing to be careful of, if I see a lot of students, they'll go krypton and then they'll go over to this side and they'll accidentally hit the wrong row. Make sure you start at krypton 36 and then you go to 37 next to help make sure you're in the right row. Antimony is all the way over here in period 5. It is in group 15 and it is in the P block. We start with xenon, then we go 54, 55 is next, 6s2, 4f14, and then 5d7, so we're in here, 1, 2, 3, 4, 5, 6, 7, that would be iridium, IR. And really, you don't even have to follow it all the way from xenon if you don't want. Actually, you could just look up 5d7 and go, okay, here's 5, here's the D block, and then count 7 in. You don't actually have to follow it from the beginning. So we've got iridium, which is in group 9. So group 9, period 6, and it is in the D block. I believe this is the last one. So let's just do it this way. 4d10. 4d, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got cadmium. It is in group 12, it is in row 5, and it is in the D block. So that's how you do those. Oh, I guess we got one more. Never mind. Stick with me for a little bit longer. Argon, 4s1. Boom, we've got potassium. Row 4, group 1, S block. And there we go. I believe that will, there we go. That will end this video. Thank you for sticking with it all the way to the end. Let me know if you have any questions on these next time we meet.